Today's video is going to be on 4 different things, and those are exponent rules, absolute value, simplifying radicals, and prime factorization. So it's pretty extensive. So the very first thing I want to talk about is exponent rules. And so what I'm going to do here is I'm going to give you those rules, and then I'll show you a couple examples of those rules. And so first off, I just want to give you the definition of each of these. So the exponent rules, there's 6 of them, and you will need to know these rules. So we have an x to a power, an x to another power. What do we do when we have multiplying? We add the exponents together. We have an x to a power divided by x to another power. We subtract the powers. We have a rule x to a power all raised to a power. We multiply those powers together. We have, if we have 2 things all raised to a power, we take each one of those things to the power. If we have a quotient raised to a power, then you take each one of those to the power, but we divide those, so that's a B. Negative powers, I don't know what you remember about negative powers, but negative power just means 1 over the positive power. And then there's one more rule, that anything to the 0 power is equal to 1. So I didn't put that in there very well, but if you'll copy down those rules for exponent rules, that'll help you in this next section. So hit pause and make sure you have those rules written down. The next thing I want to remind you about is absolute value. And basically what you want to remember about absolute value is absolute value. If you write yourself a note, absolute value is always positive. So if you have an absolute value of a negative number, that will be positive. And if you have an absolute value of a positive number, that will be positive. So absolute values aren't real tricky, but that's the rule. The third thing that we're going to discuss today is simplifying radicals. And simplifying radicals means that if I give you a square root, you're going to be asked to simplify that square root. In other words, if I give you the square root of 75, you won't be asked for the decimal value, but you'll ask to be simplify this, and it will look something like, take perfect squares out of that. The square root of 75, we break that into perfect square. And the square root of 25 and 3, why did I pick 25? Because the square root of 25 is exactly 5. The square root of 3 is not perfect, so we would just simplify that to 5 square roots of 3. So that's the third thing that we need, and that'll probably be the hardest. And then the prime factorization, that is a term that I think I'm just going to give you guys an example of. It's kind of a vocab idea, and the vocab here is, let's remember what prime means. Prime is a number that only has 1 and itself as a factor. So let me give you a couple examples of a prime number. 2 is the first prime number. 3 is prime. Why that's so thick. Let's see if I can get it a little thinner. 5 is prime. 7 is prime. 9 is not, because the factors of 9 are 3. So when we're asked for prime factorization, you're going to be asked, let's say the prime factorization of 42. Okay. So one of the things you might think of as 42. The two numbers that multiply to be 42 are 6 and 7. But 6 is not prime, so you would further break that down to 2 and 3 and 7. So 2 times 3. Now let's look. Are we all prime? Each one of these numbers is prime. So the prime factorization is of 42 is 2 times 3 times 7. Okay, so those are the 4 things that we'll be going over today. I'll give you a couple examples of each and go from there. So take down the basic notes for today's lesson, and then I'll give you some examples.